This is the beginning of part 2 of our module on convertible instruments, which discusses the mechanics, pricing, and some regulatory and accounting aspects of mainstream convertible instruments. We remind you that this part 2 contains chapters 3 and 4 of the module, with chapter 3 reviewing reverse convertibles, exchangeables, and reverse exchangeables, and chapter 4 introducing mandatory convertibles of various kinds. This chapter 3 introduces reverse convertibles, exchangeables, and reverse exchangeables, in each case making sure to address thoroughly how their structure and pricing differ from a regular convertible. It also reviews the attractions and risks of these alternative structures for both issuer and investor. The first alternative we examine is the reverse convertible, a term sheet for which is provided here. So far, the skeleton of the term sheet is identical to what you've seen before, but now comes the coupon, here it is, and the conversion clause, here it is. As before, we appear to have here an instrument consisting of a straight bond and an equity option. But three important differences versus the regular convertible that we examined in the previous chapters can be identified. First, this time it is clearly the issuer that has the option to convert, not the investor. Second, and presumably for this reason, the coupon this time is higher than the 7% available on straight debt rather than lower. And third, since the option entitles the issuer to deliver shares instead of the bond's face value in cash, this option would appear to be a put option this time rather than a call option. In summary, whereas we could draw previously for the regular convertible a diagram looking like this, and we could write convertible equals straight bond plus call option, here we would draw a diagram looking like this, and we would write the reverse convertible equals straight bond minus put option. You should take note, we emphasize again, of the minus sign appearing on the right between the two bubbles. We turn now to the worksheet labeled Reverse Convertible, which contains largely the same entries as our previous pricing worksheets, except that the call option has been replaced with a put option in cell H5, obviously, and the formula for the value of the convertible bond has been adjusted or modified to subtract rather than add, as we previously did, the value of the embedded puts from the value of the straight pure bond. Note in particular that since the term sheet permits the issuer to deliver 3 shares of common stock instead of paying the $100 in cash at maturity, then the implied strike price of these puts is $33.33 versus $50 previously in the case of the call options. From this worksheet, we see that the fair value of the reverse convertible, once again ignoring a whole number of inaccuracies that would complicate our life too much, comes to $100.15, so pretty close to the $100 price at which this instrument is issued. Importantly, we emphasize again the pure bond component this time, of course, is worth well above par, since it constitutes a straight debt instrument with a 10% coupon, but to which a 7% discount rate is appropriately applied. This next worksheet, labeled RC IRR, obviously for reverse convertible IRR, plots in column G the IRR of the reverse convertible, as usual, against the price of common shares at maturity. And it's easier if we simply look at the graph, which is right here immediately to the right of the table, summarizing the results, and we hope presenting no surprises. There's a maximum IRR for a pretty long stretch, but then diminishing IRRs over on the left when the devalued common shares are being put to the investor. So, what might drive an issuer to issue a reverse convertible? Most obviously, the attraction comes from the ability to deleverage the balance sheet by canceling an outstanding debt through the simple delivery of stock certificates instead of cash at maturity, and precisely when the depressed stock price is indicative, presumably, of a weakened financial condition for the borrower, which makes the need to deleverage all the more urgent. The instrument's drawback for the issuer, of course, is the high coupon the issuer must pay in return for this conversion privilege. The investor is attracted, of course, by this very same high coupon, but runs the risk that in an adverse scenario for the common stock, he will receive at maturity common stock worth far less than his original investment. Exchangeables and reverse exchangeables are next on our list and will take little of our time. These are identical to their convertible counterparts, except that the issuer of the instrument is different this time from the entity whose common stock underlies the embedded option. Thus, if I purchase a JP Morgan bond, which I can convert into JP Morgan shares, I have bought a convertible. While if I buy a JP Morgan bond, which I can convert into shares of Alcatel, I have bought an exchangeable. By the same token, if I purchase a bond issued by the Greek government, which the issuer may redeem by delivering to me shares in its national railroad, I have bought a reverse exchangeable rather than a reverse convertible. This last is a real transaction, incidentally, that was used by the Greek government as a way of privatizing the national railroad. Term sheets for each of these are appearing now in front of you and hopefully need little of our attention. Here are the skeletons, and here for the exchangeable is the coupon and the conversion clause, but with shares of company XYZ replacing shares of company ABC, and the same for the reverse exchangeable. Pricing an exchangeable or a reverse exchangeable works exactly the same way as before, and indeed is probably easier, since some of the complexities of convertibles, including the need to make adjustments for the dilution that results from conversion do not arise in the present instance. This completes Chapter 3.